most capacitors are designed with a dielectric between the plates. Now, dielectric is something like water. Okay, if you have a bunch of water molecules in here, they're going to tend to align because water molecules are polar molecules. They have a negative end and a positive end. You have the two hydrogens attached to the oxygen, and the oxygen tends to hog the two electrons, leaving the protons and the hydrogen atom exposed, and the oxygen end tends to become negatively charged, while the exposed protons are positively charged. So you got the oxygen end of the atom tending to be attracted to the positive charges on one plate, and the hydrogen end, which is positively charged, being attracted to the negative plate. The result is that you essentially get these negative ends lined up here along this plate, and the positive ends lined up here, and they tend to cancel out most of the positive charge here and most of the negative charge here. Now, the positive charge is still here in your capacitor, and so is the negative charge, because you've got an insulator in between here. And if you have water, insulated water, and you want pure water, because of course water with impurities conducts electricity very well. Pure water doesn't conduct electricity very well at all. It's a good insulator, actually. It's just hard to keep it pure, so we don't use water as an insulator very often. Okay, the point is then that as far as the electric field between the plates is concerned, you've got this positive charge here shielded by this negative charge, the negative charge here shielded by this positive charge. And what you really get with water, I think the dielectric constant is something like 80, which means that approximately only 1 part in 80 of this charge here is not shielded by the alignment of the water molecules. And we can look at that just a little more closely down at the bottom, where we see the positive and negative ends kind of chained together. They don't line up quite this nicely. Of course, you've got a lot of thermal energy in these things, and there's just really a tendency for one end to line up here and another end to line up here. Now, these molecules are going everywhere, and they don't form nice, neat chains the way I've drawn them. However, the principle is, again, that the negative ends shield the positive charge, the positive ends shield the negative charge, and you get less electric field between here. Now, what's that mean? That means that we're reducing the electric field between the plates, which means we reduce the amount of work you have to do to move a charge between the plates. That increases the capacitance, the charge over the distance. Charge over distance, that's completely wrong. It's charge over voltage. Okay? So, again, by putting this dielectric material in here, we increase the amount of charge that we can hold for a given voltage, because we're reducing the voltage for the given charge.